My name is Miss Kelly and this is Chase. We are going to do an experiment to find out if jello will dissolve in hot water and cold water. So what we have is 2 bowls, 2 packages of jello, 2 spoons, 2 containers of water, one's hot and one's cold. We have a thermometer and we have a piece of paper to record our data. So Chase, what I would like you to do is measure the temperature of the cold water and record that. Now what do you think is going to happen in our experiment? If we take a guess or a prediction of what we think is going to happen, what would you predict is going to happen when we put our jello into the 2 different waters?
The jello is going to dissolve slower in the cold water and faster in the hot water. That is what I predict.
That's a good prediction, so we're going to find out if you're right or not. So what's the temperature of your cold water?
55 degrees.
55 degrees. Okay, put your thermometer down and you can write on the paper 55 degrees. Okay, now we're going to measure the hot water. What is the temperature of the hot water? Now in other classes we've talked about the scientific method and different processes that scientists use. You're a scientist today, Chase. So have we used any of those processes yet so far? What are some things scientists do?
Socialize. Why am I slouching? Socialize. Predict. Take data.
Good. Record data.
Record data.
Yeah, that's good. What are you doing right now?
Record data.
What are you doing right now with the water?
Measuring the temperature.
Measuring is one of the processes. And what is the temperature?
It is 109 degrees.
109 degrees. So you can record that. Great. Now we're finished with our thermometer, so you can set that aside. And now we have 2 bowls. Be careful, it's very hot. So we have to be careful with all of our tools that we're using. We want to be careful. Okay, so now what you're going to do is measure. Scientists measure. We're going to measure 1 cup of water, cold water, and put it in bowl A. So you can even write bowl A, cold water. And you're going to put 1 of the packages of jello in it.
And the jello.
Do you like jello? Do you think this is a good experiment?
Of course, it's jello.
I like jello too. Now we have a timer. We're going to stir the jello for 1 minute. So you can use your spoon and I'll set the timer for 1 minute. And you're going to stir it. Have you ever made jello before, Chase? Yes. Did you use cold water or hot water? Do you remember? What was it?
In the middle. It was right in between. It wasn't too cold or wasn't too hot.
So what do you observe? Observing. What do you see happening in your bowl?
It is turning into very black liquid.
Black liquid. Dark liquid?
Darkish liquid.
Darkish liquid?
Magical darkness.
So you've been stirring for almost a minute. We have 13 seconds left.
What was that?
Okay, so that's 1 minute. Let's observe. What do you think has happened? What does it look like?
It turned into black.
Does it look any different? Sometimes if you pick the spoon up, you can look at it because you can see right through the liquid on the spoon. What was your prediction?
That it was going to be more solid, like slower to move around.
Okay, so now we're going to do the warm water and see if it looks the same. So you're going to measure. Wait, we're going to measure. How much? We want the experiments to be the same, so how much are we going to measure?
I measured it.
Lay it flat. You don't want to spill it.
There we go.
Be very careful.
Very careful, very careful, very
Let me move my hand so you can put it in the bowl. Right here, honey.
There we go.
Very good. Now when you put it even, it's exactly full. If you pour some back, it's just a little bit less. So we want to try and keep it the same. So now what do you need to add to your warm water? Right here.
Oh, put it right there. Why do you put the jello over there?
1 package of jello. The same amount in both bowls.
Who likes jello dust? I do.
Okay, now what 2 things do we need to do now to make our experiments the same? Stir it for how long?
1 minute.
1 minute. So let's start the timer.
Do 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 do
What do you observe? Do they look the same? No? What do you see that's different?
The one has a whiter top.
White or top? What do you think that is?
I don't know.
You don't know?
Air, water.
Air or water, maybe? What was your prediction about the warm water?
That it was going to be less dense.
Less dense. I think the word you're looking for is dissolve. We want the
warm water is
sugar
going to dissolve.
What do we call? Very good. What do we call when something dissolves in something else, like the sugar dissolves in the water? What do we call that? Do you know?
Evaporation.
No.
Oh, this water is red.
This is now not sugar, and this is now not water. This is something new. It's a new solution. So we have made something new.
We made a solution.
A solution. Okay, can you observe and tell me what you see in this solution?
Watery blue.
How does it compare? You should never taste your experiment unless you have been instructed to, because now you will contaminate the results. But also, we know this is safe because you trust Jello. But in an experiment,
We trust Jello, but if it was something else,
yeah, maybe
I could be dead.
It might be a chemical that isn't safe.
I could be dead.
Do they taste the same, Chase?
You didn't let me try that one, so.
Okay, because I know it's safe, you may taste that and tell me if it tastes the same.
Cameraman, you're not supposed to be talking. That is very sugary and warm.
Okay.
It tastes not as good as that.
Okay, but it doesn't probably
Actually,
taste...
it does.
Does it taste too different?
Yeah, it tastes really different.
What's different about it?
The one has more of a sugary in the liquid, and the other one has the sugar all separated.
Which one has... You could taste the sugar separated?
The cold water.
The cold water. That means the sugar didn't do what? It did
not dissolve.
It didn't dissolve as much. Very good, Chase. I really thank you for helping me with this experiment. I think now we should finish according to the directions. Put it in the refrigerator, let it get solid. I have a little whipped cream we can put on top, and you can enjoy these 2 bowls of Jello.
Remember,
Thanks.
kids, adults, unknown amounts. Be safe. If you sneeze during this video, bless you. And have fun with Jello.
Let me ask you one more thing.
What?
Would our conclusion be? What did you decide?
I
Is
decided that the warm water dissolved it better. It left less chunks, and the cold water made it very thick with the sugar molecules and particles.
Let's talk about real life application. Is there any time in real life where you mix a powder with a water or something similar?
Yes, there is.
Or a liquid?
You could mix brownie mix into a bowl and you have to stir it with water. Or other forms.
Is there anything you mix chocolate with? Chocolate powder?
That's what brownies are.
Yes, you're right. Hot chocolate? What about cold chocolate? Do you ever put chocolate with milk?
Yes. That's way better than chocolate without milk.
Why?
Because milk warmed up makes it a very thick, creamy goodness.
You're talking about hot milk
Yes.
to dissolve the chocolate. Any other times you might mix powder in a solution? A liquid and a powder.
Pancakes?
Pancakes, we made that one time, didn't we?
Yes.
Okay, very good. Thank you,
Ramen
Chase.
noodles.
Think more about this. That's great. You did a good job.
If you sneeze during this video, bless you. And if you like Jello, make sure to ask your parents to do this for you. Also, what grade is this going to?
3rd graders.
I had a fun time in 3rd grade too.
Okay.
Bye.